Now see here in this example, this is a metal bar which is of 70 centimeter long and it is supported by two knife edges K1 and K2. At the knife edges K1 and K2, reactions are R1 and R2. These knife edges are placed 10 centimeter from both the ends. It is from B, that is 10 centimeter, from A, that is 10 centimeter. And now this is the center of gravity, this is a gravity point, and now total mass of the bar is 4 kg. Now when the mass is suspended of 6 kg at this point here, at point P, which is 30 centimeter from end A, then whole system is in equilibrium. So you have to find out here the value of R1 and R2. So first we consider here the translational equilibrium. So see, the total forces acting upward are R1 and R2. So we can write R1 plus R2, and then weight of the metal bar, that is 4, that is we can write here minus 4 into 10, and this weight suspended at this point minus 6 into 10 is equal to 0. So R1 plus R2 is equal to 100, and this is coming here by assuming translational equilibrium. Translational equilibrium. So by using translational equilibrium, you have got R1 plus R2 is equal to 100. Now we can see this system is in rotational equilibrium also. So we can take the total moment of force, and that is the total torque about the point G. So what are the forces which are producing torque? So the weight of this cannot produce torque because it is actually acting at the axis of rotation only. So the R2 is going to produce torque, that will try to rotate to this side anti-clockwise. R1 will produce torque to this side, that is clockwise, and W1 also will try to rotate to this side. So we will take now the total torque about the point G due to all these three forces, and this is in the rotational equilibrium. So sum of all these torques will be equal to 0. So for the torque due to R1, we can write here, that is a clockwise, so that is minus R1 into, that is a force, into the distance from this to this gravity. So this is from 10 and this is the midpoint. So obviously this whole thing is AG is 35. So from here to here is 25. So we can write 25, and then torque due to this W1. So plus W1 is equal to 6 into G. So that is actually 60 into, this is a 5 centimeter distance because this is from 30 centimeter from end A. So this is 5. Then we can write torque due to R2, that is plus R2 into 25 is equal to 0. I have taken all these distances in the centimeters. So now the total torque is 0, so that is in rotational equilibrium. So we can write now here in that case R1 minus R2 is equal to here, that is 300, and here into 25. So we can write R1 minus R2 is equal to, here we can take, that is a 12. So there are two equations, one is first and this is one is second. If you solve first and second equations where R1 plus R2 is equal to 100 and R1 minus R2 is equal to 12. So see here, this R1, R2 and R2 will get cancelled. So you will be getting twice of R1 is equal to 112. So you will be getting R1 is equal to 56 Newton. Now R1 is equal to 56 Newton. So R2 you can get. So R2, just by putting the value in equation 1, so you will be getting R2 is equal to 44 Newton. So there are these two values R1 and R2 we have calculated by using the concept of rotational as well as translational equilibrium.